To oversimplify enormously, photons are tiny particles of light. Electrons and photons behave similarly, and both obey quantum laws. But because we can actually see photons as light, they're ideal for this experiment. From the laser apparatus, single photons fire off one at a time. The individual particles then arrive at a plastic barrier with 2 narrow slits. On the other side is a sensitive TV camera to film where the photons end up.
And so the photons will hit the film. What do you expect? You expect we'll hit 2 spots here, like that, or you expect the photon will go all over the map. What do you expect? We have 2 slits here.
The choices are all over the map, or just those 2 spots?
Just 2 spots, yeah.
Just the 2 spots?
Exactly. Mark is using his common sense. Imagine this experiment was blown up to a much larger scale so that the particles are tennis balls, and a machine is firing the tennis balls at a barrier with 2 gaps in it. Of course, you'd expect to find the balls hitting the back wall in 2 places, in line with the 2 slits. But when our experiment is done with individual photons from the laser, something very different happens.
Okay. You see the screen up there?
Yep.
That's what we see from the camera. See those individual flashes?
Oh,
there?
yeah.
Those are the photons.
Each flash of light is actually an individual photon hitting the back wall. They appear to be landing all over the place. But watch over time and a pattern emerges.
Can you see somewhere in the middle of the screen?
It looks like a smudge.
Yeah, it looks like a smudge.
Yeah.
Those are the photon, where the photon hits. But it's not 2, as we would expect. Is that weird?
Yeah, so why is that?
That's right, why is that?
Instead of the 2 vertical bands that you'd expect, a series of vertical smudges appear. To make sense of this pattern, you need to look at it from the perspective of a single photon. This photon is landing in a place on the back wall that would be physically impossible if it were travelling straight through just one of the slits. So, the only explanation is that the particle has gone through both slits simultaneously. By the time it reaches the back wall, it has come together again as one photon. Multiply this single photon 1,000-fold, and you have the distinctive pattern that Mark saw. Think about it. A photon arrives at the slits in a hell of a quantum state and travels through both. A single object is in 2 places at once.
Now you're blowing my mind.
Good, that's our job to do, to blow people's mind, so make you think, right?
Whew, my brain hurts.
Okay.
I wish I was back home playing my guitar.
And it's not just photons that behave like this. The double slit experiment has been replicated with electrons and with atoms. But we are made up of atoms. So atoms can be in 2 places at the same time. Why can't we?